Hello students, this is your Semester 2 Unit 7 test review. If you have not already played Kahoot on your own, you will need to play it when you are finished with this recording to see if you can get the answers on your own and then take the Unit 7 test. So let's go ahead and get started. Which Lewis dot diagram shows an atom that needs 3 or more electrons in its outermost shell? Well, remember, it needs 3 more. Remember the magic number? The number that is the most stable valence electrons is 8. And so if it needs 3 more, it must already have 5. That would be nitrogen. All right, I got it right. Here we go. So, next. The energy required to remove an electron from its shell is polar energy, electron energy, ionization energy, or quantum energy. Well, I think Santa Claus might need the polar energy. Electrons do have energy, but that's not the energy needed to remove them from a shell. Quantum energy might be just a little more complicated than what we need, so it's ionization energy, the energy needed to remove an electron from its shell and make that atom into an ion. Ionization energy. Okay, atoms with the same number of valence electrons are arranged in rows, columns, diagonals, or stair steps. Same number of valence electrons. Remember, that would be the groups. Groups are vertical, periods are horizontal. Vertical groups would be columns. All right. There we go. Number 4, the electrons in the outermost shell that are available for bonding. What do we call those electrons in that outermost shell available for bonding? Excitable electrons, valence electrons, inner electrons, or bonding electrons. If they're in the outermost shell, they're probably not inner electrons. They may be excitable, they may not. We don't really know that. They can be used for bonding. That's not actually the name of them. They are the valence electrons in the outermost shell available for bonding. They're called valence electrons. Alrighty, number 5, an atom that has 5, 6, or 7 valence electrons will gain electrons, lose electrons, always form a covalent bond, always form an ionic bond. Well, keep in mind that every time an electron is moved from one atom to another atom, energy is required. It takes energy to do that. So if they already have 5, 6, or 7, then they only need 3 or 2 or 1 more. It's more expensive energy to move a lot than a little. Well, these already have a lot. So they're not going to move those. That's too much energy. Instead, they're going to gain electrons to reach 8. All right. Metals that have 1 or 2 or 3 valence electrons will, well, we just had that conversation about having a lot of electrons versus a few valence electrons. It always takes energy. Well, these are only a few. So even if we do have to move them, it's not going to be that much energy. So they are going to donate or move or get rid of or give away their valence electrons. Donate. Donors and acceptors, right? Metals are the donors and non-metals are the acceptors. Number 7, to complete its outermost shell, oxygen will accept some electrons and give up others, accepts electrons, gives up electrons, or moves electrons from the inner shell to the outer shell. Well, we've never discussed that. We have never once talked about moving electrons from one shell to another, so that's probably not the answer. We can see that oxygen has 1, 2, 3, 4, 5, 6 valence electrons. It could use 2 more to reach 8 and be most stable. Is it more energy to remove 6 or to get 2 from somewhere else and add them here? It's going to be too much energy to get rid of 6. It's a whole lot less energy to get 2 from other atoms and put them here. So oxygen is going to accept electrons. And remember, oxygen is on the right side of the periodic table. It is one of those nonmetals, and nonmetals are acceptors. But I hope Mrs. Levinson doesn't get any of these wrong, right? All right, next. Number 8, 2 atoms share electrons to form a chemical bond. 2 atoms share electrons. Sharing. Ooh, we talk about electron sharing here. A 007 bond. Sounds a little spyish and suspicious to me. Ionic bond. I don't know about that sharing part. Covalent bond, sounding more familiar. And a hydrogen bond. Well, we know ionic bonds are the ones where a metal gives electrons to a nonmetal. That's giving away, so not an ionic bond. A 007 bond, probably not a movie. All right. Hydrogen bonds are not actually sharing anything. It's an attraction of those positives and negatives, more similar to an ionic bond. But the covalent bond, by definition, is sharing electrons, like in water, where the oxygen shares electrons with hydrogen, or in oxygen gas, where one oxygen shares electrons with another oxygen. All right. I must be doing pretty well. The attraction between oppositely charged atoms is which type of bond? Attraction between oppositely charged atoms. Is it ionic, metallic, hydrogen, and covalent? All right, because it's oppositely charged atoms, here they're talking about within the same molecule or crystal. That's why it's going to be an ionic bond, not a hydrogen bond. Oppositely charged atoms means one atom is positive and one atom is negative. That's why it's not a metallic bond, because remember, all of the atoms in metallic bonds are positive. All of them are positive, and only those negative electrons are moving between them. This is atoms that are opposite charges, a positive and a negative atom. Metallic bonds are all positive atoms. That's why metallic is not right. And covalent is sharing electrons. There's no actual difference in charges that's causing an attraction. They're just sharing electrons. So ionic bond is the right answer here. The attraction between oppositely charged atoms, like a sodium atom is positive and a chlorine atom is negative. That hydrogen bond will specifically say something about one molecule and another molecule. If it's just talking atoms, it's going to be the ionic. Alrighty, here we go. 10. Most ionic bonds will form when elements from A bond with B. So we got to look at our colors up here. Here's A, that tan color. B is this blue color. C is the red color. And D is the green stair step. So ionic bonds, we have to remember the definition of ionic bond, where a metal atom gives an electron to a non-metal atom. So if we know where the metals and the non-metals are, this is probably an easy question. So remember, metals are on the right side. That looks like A. Non-metals are on the left side, which could be the blue or the red, but remember the red have 8 valence electrons. Those are our noble gases that do not react with anything else because they're already stable. Their signature property is that they are non-reactive. So that leaves these blue ones. These are the non-metals, and those are B. So A and B, and that's this one right here. All right, good job. Covalent compounds occur. Oh, same thing. We've got our same periodic table. So we know we got our metals. We got the green stair steps are the metalloids. The blue ones are the nonmetals. And then the red ones are the noble gases. So what we have to do here is remember the definition of a covalent bond. Covalent bonds happen only between a nonmetal and a nonmetal. So only these over here are going to form covalent bonds with each other, not with anything else, only with each other. And so only between nonmetals. That's just a straight definition. All right, 12. Which type of bond forms when two or more atoms share electrons? I think we've already covered that. Sharing of electrons is going to be covalent. Remember, hydrogen is an attraction between atoms and different molecules. Ionic is an attraction between atoms in the same crystal lattice, metal and nonmetal. And equal is just a word, random word. So covalent bonds is sharing of electrons. Number 13, covalent bonds form because most atoms seek to have how many electrons in their outer shell? The real question is, how many electrons in the outer shell? Atoms seek to get how many electrons in the outer shell? 2, 1, 4, or 8? Well, you already know that answer. 8, right? 8 is the magic number. There we go. Good job. Number 14, which molecule has a double covalent bond? Well, we know covalent means they're sharing. So sharing a double means sharing a double set. A single covalent bond is one pair. A double covalent bond is two pair. There's a pair and there's a pair. And a triple covalent bond is three pair. There's a pair, there's a pair, and there's a pair, right? So the double covalent bond would be B. And number 15, which type of bond is molecule C? Which type of bond is molecule C? Well, count up how many pairs you see. In A, I see one pair. In B, I see two pair. And in C, I see three pair. Three pair. 3 is triple. Must be a triple covalent bond. Number 16, what is the most accurate name for this ionic compound? The MgCl2. Most accurate name for this ionic compound. Well, remember our rules. First, name the metal. Second, name the nonmetal, the nonmetal. Third, change the ending of the nonmetal to IDE. Those are our simple rules for ionic compounds. The Mg is magnesium, the Cl is chlorine, but in ionic compounds, we don't use those prefixes, right? So while it is magnesium and chlorine, this didn't change the ending to IDE. This one uses prefixes. All three of these are wrong, but magnesium chloride is the right one. It named the metal, it named the nonmetal, it changed the ending to IDE. Number 17, what is the most accurate name of this ionic compound? The ionic compound is, I'll have to adjust this, but the ionic compound is BE capital O. And remember, only use the rules we learned in this class, nothing from the internet. So BE capital O. All right, ionic compound, name the metal. Beryllium, 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 beryllium. Okay, so that doesn't help us, right? Name the nonmetal. Oxygen. There's oxygen, there's oxide, there's monoxide, and there's oxygenide. Well, we know we don't use any prefixes, so blue is wrong. We change the ending to IDE, which means red is wrong. We don't just add the IDE onto the end, we actually change the word. Don't just stick it on the end. That's why the green one is wrong. So beryllium oxide, because it actually changed the ending. Good job. All right. Number 18, what is the most accurate name of this covalent compound? The covalent compound here, I'll add a space in there just so it's easier, but the covalent compound here is N2O3. It is covalent, so let's do the other set of rules. Name the first element first. Well, that is nitrogen. They all start with nitrogen, but some of these have prefixes and some of them don't. When we do covalent compounds, we do need prefixes. The only prefix we can sometimes leave off is mono, but this has two, which is di. So di-nitrogen. That means blue and yellow are wrong. Dinitrogen is what we start with. Could be red or could be green. Then the capital O is oxygen. We have to use the prefix tri and change the ending of oxygen to the IDE. So dinitrogen trioxide is red. Number 19. What is the most accurate name for this covalent compound? NBr3. Only the rules from class, right? Covalent. Name the first one first. Nitrogen. Use the prefix if it's more than one. Well, it's only one. We don't really need the mono. That means the green one we probably could mark off our list, but it could be red, blue, or yellow. Name the second one second. That's bromine. You might need a periodic table to do these, guys, okay? Bromine. And there are 3 of them. Tribro. And then we have to change the ending of the bromine to an IDE. Tribromide. Nitrogen tribromide. All right. Number 20, what is the most accurate name of this covalent compound? Always good to practice covalent compounds. Be sure to use the rules from class. P2O3. P is phosphorus. There are 2 of them. Di, and remember with covalent compounds we have to use those prefixes. Diphosphorus. Well, that would be red or green. And then we have oxygen. There's 3 of them. With covalent compounds, we have to use the prefixes. So tri, ox, and then we have to change the ending to IDE, trioxide. Diphosphorus trioxide. 21. Which type of bond has an unequal sharing of electrons? Unequal sharing of electrons. Non-polar covalent, electronegative, ionic, or polar covalent. Equal sharing would be non-polar. There's no difference between the poles. Unequal sharing would be polar. There's a difference between one side and the other side. Whoop. Polar covalent. Number 22. Which statement is true about metals? Remember the periodic table. Metals are on the left, non-metals are on the right. Remember some things about metals. Metals have 1 or 2 or 3 valence electrons. They are shiny, malleable, ductile, good conductors, solids at room temperature, except for 1. So which one fits all of those categories? And because they only have 1 or 2 or 3 valence electrons, they do easily give them up. 23. What type of bond does this picture show? What type of bond does this picture show? You can see that the sodium gives its 1 single valence electron to the chlorine, and you end up with a positive, there's a little positive sign, positive sodium ion, and a negative chlorine ion. and a positive attracts a negative. By definition, I have a metal and a non-metal. Sodium is a metal, chlorine is a non-metal. I know that because I can look at it on the periodic table. And yes, you are allowed to use a periodic table on your test. It just has to be a plain, simple one. It is an ionic bond. Which is the correct Lewis dot diagram for nitrogen? Which is the correct Lewis dot diagram for nitrogen? Well, if you look up a periodic table, you will see that nitrogen is in group 15, and so it should have 5 valence electrons. The only one with 5 valence electrons is D. Or C. Sorry, 2, 4, that's 6. Sorry, C has 5. 1, 2, 3, 4, 5. I knew I was going to mess one of them up. I did say 5. I just picked the wrong picture. Oh, well, you know. Here we go. Number 25. Which statement is true about writing chemical formulas of covalent compounds? So we're looking for a rule for covalent compounds. One rule is correct, the other rules are not for covalent compounds. Do we swap and drop the charges? So we're doing chemical formulas, the rules for chemical formulas. Swap and drop the charges. Well, covalent bonds don't have charges. Use a prefix to indicate the subscripts for each element. Remember, the subscripts are the numbers, so like O2. If it's O2, it would be dioxide, right? Write the symbol for the cation and the anion. Well, covalent compounds don't have cations and anions. Those are ionic compounds. So red and yellow are wrong. Simplify the subscripts to the smallest ratio. Well, remember in covalent compounds, we don't simplify because all of those atoms are actually present in a single unit. So it has to be blue. All right, got it right. Shoo! Here we go. 26. Find lithium and silicon on the periodic table. How many valence electrons for each element? Well, lithium, right here, Li, is in group 1. And that means it should have 1 valence electron. Has 3 electrons total, but only 1 valence electron. That means it could be blue or yellow. We can tell by looking at the periodic table, so red is wrong. And the other one is silicon, Si. Silicon, Si. It has 14 total electrons. It's in group 14, but only 4 of those 14 electrons are valence electrons, so green. Lithium has 3. Lithium has 1. Silicon has 4. Well, I obviously picked the wrong answer. I'll fix that one. Lithium has 1. Silicon has 4, not 14. It should be this one right here. It should be the correct answer, okay? Should be the correct answer. Lithium has 1 because it's in group 1. Silicon has 4 because it's in group 14. How does a cation form? How does a cation form? Okay, that is probably not it. It adds electrons. Well, electrons are negative. If you're adding electrons, you're adding in negatives. Negatives are anions, right? Add protons. Well, you can't add a proton and still have the same element, so that one has to be wrong. Take away electrons. Electrons are negative. If we get rid of those negative electrons, it becomes a positive ion. By definition, positive ions are cations. You cannot take and remove protons. That's not the right answer. All right. Number 28. Which of these numbers represents the charge of an anion? The charge of an anion. Ions that are negative. Only one of these is negative. Number 29, why do noble gases not participate in chemical reactions? Well, remember, noble gases are that very last column, group 18. They have 8 valence electrons. 8 valence electrons means they are already stable and they do not need to react. so they do not need all of their electrons and neutrons. Well, they do need them all. They only react with water under high pressure. Well, they just don't react, so that can't be right. They have a full outer shell of electrons. They do, because they already have 8, and so they do not react. All right, has nothing to do with protons in the nucleus. Number 30. What type of bond is unequal sharing of electrons? What type of bond is unequal sharing of electrons? Where one has a slightly positive charge and the other has a slightly negative charge. I can see a positive pole and a negative pole, so it must be polar covalent. I'm not asking you, I'm telling you that actually is the correct answer. I'll take the question mark out of there. All right, by the time you guys take this Kahoot, they'll be corrected. So you will see the correct answer says correct. What is the most accurate Lewis dot diagram of phosphorus? Group 15. If it's in group 15, it must have how many valence electrons? 5. Let's see if I can count properly this time. Well, 2, 4, 5, 6. It's not A. 2, 3, 4, 5. Probably right. 1, 2, 3, 4. Nope, that's not enough. 1, 2, 3. That's not enough, so it's got to be B. 5 valence electrons. Oh, I counted right this time. All right. Number 32. I know the rules for naming ionic compounds and covalent compounds, and I know how they are different. I know. Do you know? If you do not, go review the rules. Number 33, I know the rules for writing chemical formulas and ionic compounds and covalent compounds and how they are different. And if I know the rules, but do you know the rules? If you do not, go review the rules. Number 34, ionic bonds form between. Remember on the periodic table, the left are the metals, the right are the nonmetals. Ionic bonds are when metals give electrons to nonmetals, so it must be metals and nonmetals. All right. And last but not least, on the periodic table, which are the metals and which are the nonmetals? We have said over and over and over again, metals on the right, nonmetals on the left. It must be this one. All right. Great job. Remember, if you get them all correct, you should have a score of 35,000. I got a couple wrong, not because, well, I had one wrong because I counted wrong, but I will fix those that had any errors in them. By the time you get this, yours should not have any errors. If you have any questions, send an email. Have a great day.